Okay, guys. Today we're going to be learning how to multiply and factor monomials. We already know what a monomial is. A monomial is a one-term polynomial. What does a one-term polynomial mean? Well, that means that a monomial should be, not should, is a number, a variable, or the product of numbers and variables, where the variables have positive whole number exponents. If I have a variable with a negative exponent, it's not a polynomial. If I have a variable inside of a radical, it's not a polynomial. If I have a variable in the denominator with a positive exponent, it is not a polynomial. Okay? So, we're going to deal with that today. In order to multiply, though, by and factor out monomials, you must remember your power or exponent rules and the distributive property. If you know your power rules, the distributive property, that's it. You've already done with this lesson. I could probably just close the PDF right now and give you the homework, and you will be able to do it if you know your power rules and distributive property. So, just in case, I know we just had a test on this, but just in case, let's go over them again. Okay, power rules. A to the m times a to the n equals a to the m plus n. Please remember that when you multiply the same base, you simply keep the base and add the exponents. Done. Number 2, a to the m divided by a to the n equals a to the m minus n. Please remember that when you not multiply, but when you divide the same bases, sorry, but guys, screwed up here. When you divide the same base, you simply keep the base and subtract, sorry guys, the exponents. So when you divide the same base, you keep the base and subtract the exponents. A to the m raised to the n power. Whenever I raise a power to a power, okay, it's going to equal a to the mn. I keep the base and I multiply the powers. All of this we should know hands down. I mean, just boom. If you don't, well, guess what? You just got to review. Now, distributive property. When we talked about distributive property before, we had said that, oh, you multiply the outside number to everything. Well, now we don't have to have just a number out there. We can have a monomial. We can have a monomial, which is one term. And basically what's happening is you're taking that monomial, the outside monomial, and you're multiplying it to everything, giving you NA, N plus NB, plus NC. So, remember that the distributive property allows you to multiply the outside term, the monomial, by every term within the parentheses. If you know these 4 little things that I just went over, you know how to do the lesson already. Okay, now that the review is out of the way, let's get to business. Simplify each. In other words, find the product. My friends, it's literally what I just finished talking about. You're going to literally distribute the outside monomial to every single term inside of the polynomial. So let's do it. What's negative 2x squared times 5x cubed? Negative 10x. Negative 10x to the 5th. For those of you that are saying the 6th and the 4th and the 3rd, we just finished going over this. When you multiply the same base, gentlemen, you keep the base and add the exponents. If you do not know how to do these basics, you will not go very far in this chapter. I have already asked you to please review. I am asking you once again to please learn your chapters. Please and thank you. So negative 2x squared times 5x cubed is negative 10x to the 5th. Because x squared times x cubed is x to the 5th. You keep the base and add the exponents. Negative 2x squared times a negative 4x squared. Plus 8x to the 4th. Good. Then, negative 2x squared times positive 3x. Negative 6x cubed. Very good. And last but not least, plus 8x squared. Very good. Excellent. Great job. Just out of curiosity, what would the name of this polynomial be? By degree and term number? Sir? No, it's a 5th degree 4-term polynomial. You said 5th term. I don't understand that. The highest degree is 5. That's a 5th degree 1, 2, 3, 4-term polynomial. Again, we just finished this yesterday. If you guys, I told you this. If you guys don't learn the proper vocabulary of this chapter, you are going to be in a world of hurt. I keep telling you this, and you keep ignoring me. It's your choice. Next. Okay. I got 3y times parentheses 2y squared plus 5y minus 3. Talk to me. You're going to distribute the 3y to every single term. Good man. What do I get? 6y cubed. Very good. Plus 15y squared. Great. Excellent, son. How would you read that by degree and term? Cubic. Very nice. Cubic trinomial. Nice, dude. Nice. Well done, son. Awesome. Awesome. Okay, next. What do we got here, guys? Yes, sir. Okay. You're going to distribute negative 5x to the 5th to everything. And he said my first value, negative 5x to the 5th times 2x to the 4th, is negative 10x to the 9th, which is 100% correct. Awesome. Oh, yeah, 15x to the 8th. Great. Minus 5x to the 7th. Awesome. Plus 20x to the 5th y. Son, why didn't you combine these and say xy to the 6th? Believe in yourself. That was a trick question. The answer is, Mr. Morrow, you can't do that because they don't have the same base. See, I threw a curveball at you and I got through. Strike out. Believe in yourself, my brother. You knew what you were doing. I'm proud of you. Believe in yourself. This will never combine because they're not the same basis. X and Y are not the same basis. Yes, sir. The highest degree is 9, which that is the highest degree. What is the degree of this here? Yeah, this is still the highest degree. Thank you, sir. Yes, sir. Oh, yeah, what's the name of this polynomial? 9th degree, 4-term, bless you, polynomial. Fantastic, brother. Awesome. Good job. All right, next. Now, let's go to factoring. Factoring monomials. Okay, when we're factoring monomials or the GCFs from polynomials, so easy, guys. What's happening here is, in order to understand factoring monomials from polynomials, you must remember what a factor is, first of all. A factor is any real number that goes into another real number evenly, without remainder. Without remainder. So, for example, and I forgot one factor here. The factors of 20 are 1, because 1 times 20, 1 and 20, 2 and 10, and 4 and 5. Those are all of the numbers that go in evenly into 20. So those are factors. Please remember that factors are always less than the original number. Factors are always less than or equal to the original number. Factors are always less than or equal to the original number. A factor will never be larger than the original number. It doesn't make sense. Okay? So, that's what a factor is. What is the GCF? What is the greatest common factor? The GCF, or the greatest common factor, is the largest common factor between two or more terms. For example, the GCF of 70 and 40 is 10. Why? Because it is the largest number that divides evenly into both 70 and 40. That is what a GCF is. Now, how does this apply to polynomials? Very simply. In essence, guys, factoring a polynomial reverses multiplication. Okay? It is the opposite of multiplication. Do you guys remember when we were solving equations like 2x equals 10? What's the relationship between the 2 and the x? They're being multiplied. How do you cancel multiplication? Okay, so when you divide, you're reversing multiplication, right? Same concept here for when you're factoring out a monomial or a GCF. The factoring of a polynomial reverses multiplication. So when you're factoring any polynomial, the first step is to find the GCF, if any. Then I'm going to factor out that term. And I factor out that term by dividing the GCF to every term inside of the polynomial and placing the GCF outside of the parentheses, like so. You're always going to put the GCF out here, and then you're going to multiply it by the first term divided by GCF, the second term divided by GCF, etc., etc., etc. What's left inside of here, that's what I call the leftovers. Okay? Now, finding the GCF of numbers is pretty simple. You've been doing that since like 4th grade. However, when you want to find the GCF, please listen to this, guys. Please, please, please. When you want to find the GCF of a variable, pay attention. The GCF of like variables always belongs to the variable with the lowest exponent. For example, find the GCF of x to the 6th, y squared, z to the 5th, and x to the 8th, y to the 5th, z to the 3rd. Okay, what is the GCF of the x's? 6, because isn't 6 less than 8? You go to the lowest variable exponent. What is the GCF between the y's? Y squared, because that's lower than 5. And what is the GCF amongst the z's? 3 cubed. So that is my GCF. The GCF of any variables, whenever you have variables involved, the greatest common factor of variables belongs to the variable with the lowest exponent. That's exactly right, sir. And that's it. Now, let's do it. Let's get to work. I'll show you how to do this. Really simple. Okay, guys, first things first. Always. What's my GCF? 5x to the 3rd. Very good. Why is that my GCF? Because that's the largest number that can go into 5, 20, and 15. And that is the largest variable exponent that can go into x to the 5th, x to the 4th, and x to the 3rd. So your setup is always going to be your GCF times the leftovers. How do you get the leftovers? Divide every single term by the GCF. What is 10x to the 5th divided by 5x cubed? 2x squared. Very good. Plus 4x. Good. Minus 3. Just 3, son. X cubed divided by x cubed is x to the 0, which is 1. Remember, anything divided by itself equals 1. So x cubed and x cubed, they cancel out. That's my answer, boys. See how we're using power rules? You're going to be using the power rules, just like I promised, for the next 3 or 4 chapters. So learn them. Sir. The question is, where did I get the x to the 3rd? Didn't I just finish saying that the GCF of variables belongs to the lowest exponented variable? Isn't x cubed the lowest exponent variable? That's how I got my x cubed. Yes, sir.
And you got the 5 from adding the 10 to
No, I didn't add anything. What goes into 10, 20, and 15, guys? Guys, did I not just talk about what a factor was? Then why do you guys say, yes, yes, I get it, and then what? Why don't you just be honest with me from the beginning, and then we don't have to go backwards and forwards? Sir. How would you simplify 5x to the third out of curiosity? If you distribute it, you go back to the original equation. To the original expression, rather. Why would you do that? If I said factor it out and you factored it out, why would you put it back in? So when I say drink your milk, do you drink it and then spit it back into the cup? You drink it and then it's done, right? Same thing here, guys. Once you have factored out the GCF, you have factored it out. You are done. It is over. It's done. If you distribute 5x cubed back, you're going to end up with the original expression again. So no, do not do that. Thank you. Okay, I got to hurry up. This is taking longer than I had expected. Okay, let me erase this actually. Okay. What's the GCF here? GCF is 4y cubed. So you're going to go 4y cubed times, divide that by 4y cubed, divide that by 4y cubed, divide that by 4y cubed, equals y cubed minus 7 y to the 6. Good. Not plus 4y, just 4. Because y cubed divided by y cubed, anything you divide by itself is 1. And this is it. That is the factored form. You're done. You're done. That is the factored form, guys. Okay? That is the factored form. Okay, next. We got this bad boy here. What's my GCF here? It's not 3 because 3 does not go into 14. It's just x. My GCF here is just x. So this is going to be x times 9x cubed minus 21x plus 14. That's exactly right. Why? Because I divided that by an x, divided that by an x, divided that by an x. Does that make sense? Now, let's put it all together. Find the shaded area. Find the area of the shaded region. What do we have here in that picture? What do we have here? We have a circle and we have a square. How do we find the area of the shaded region? Thank you. You're going to find the area of the square. Awesome. Then you're going to find the area of the circle. And you're going to subtract the two, guys. Does that not make sense? If I take out the circle, then I'm left with the shaded part. And that came out artificially. I wanted to ask you the question. But to find this, we need to know the area of the circle. And the area of the circle is pi r squared, where r is the radius. To find this, we're going to have to find the area of the square, which is side squared, because all sides are equal in a square. So in order to figure this problem out, we got to first find the area of the square, and then minus the area of the circle. So what is the area of the square, my brothers? Yes, guys, remember, area equals side squared, which is 4x squared. So that's going to be 16x squared. Awesome. Minus area of the circle equals pi r squared. So this is going to be pi times 2x squared. So what will that give me? 4x squared pi. Because 2x times 2x is 4x squared. Didn't we just go over the rules Didn't we just do this? So that's 4x squared. What was your question, son? No, I want you to leave this. I will tell you, if I tell you leave in terms of pi, that's what I want in terms of pi. If I wanted you to figure out the actual value, I would say round your answer to the nearest hundredths. Remember that in the SAT or the teachers. If they say leave in terms of pi, that means leave pi just where it is. Leave pi as pi. If they say round to the nearest hundreds or thousands, then you actually multiply everything by 3.14. Yes? Okay, yeah, we're not done yet here. Talk to me. What? Okay, that is completely wrong, sir. You cannot add 16x squared minus 4x squared pi because they're not like terms. But what you can do is factor out the GCF of 4x squared, leaving me with, guys, if I factor it out, I factor it out from every single term. So I'm left with 4 minus pi. And that, and of course, units squared, because it's an area. That's how we do that. Thank you very much. May God bless you. Have a great day.